Hello and welcome. In this video, we will start the design process of magnetic internal gearbox. Here is our design. In this design, we have two gears, large gear and small gear. The large gear rotates at lower speed, about 100 RPM in clockwise direction, while the small gear rotates at about 500 RPM in clockwise direction. Large gear contains 10 ball bearings, while small gear contains 2 ball bearings. The gear ratio here is about 5, and the magnet is made from neodymium N48. The iron here is from M1929G material, and it is a type of ferromagnetic materials that is well defined in ANSYS Maxwell library. The thickness of this model is about 10 millimeter, as shown here, for both large gear and small gear, and also the back iron. We can do this design in 2 dimension or in 3 dimension, but in this video I will start with the geometry of the large gear in 3 dimensions. Note that the width of the magnet here is about 2 millimeter, and the back iron width is about 3 millimeter. The distance between permanent magnets here is about 2 millimeter. The diameter of the large gear is about 100 millimeter, while the diameter of the small gear is about 20 millimeter. So now let's start with the geometry of the large gear. Let's go to ANSYS Electronics Desktop and go to project here and insert Maxwell 3D design. Now this is our project. We can rename it as magnetic gearbox, and this is our design here. We will rename it as internal magnetic gearbox, and right click on this design and go to solution type, and select the solution type to be transient and click OK. Now let's start with the geometry of the large gear, which, as we said, consists of magnets here and the back iron. So we will start with the cylinder that contains the magnets. Go to add cylinder here and insert this cylinder like this. The diameter of this, or the radius of this cylinder, will be equal to diameter d of large gear outer diameter. And this should be 100 millimeter, and here we can divide this by 2. The height will be equal to height of large gear, and it's equal to 10 millimeters, and here minus height of large gear divided by 2. And here use 100 segments for the cylinder and click OK like this. Now this is the cylinder that contains the magnets for the large gear. We will copy it and paste here like this, but this time we will change the radius only to be the inner diameter for this cylinder, and its length will be equal to 96 millimeters, and click here apply and then OK. Now you can subtract cylinder number 2 from cylinder number 1 as shown here, and go to insert a box like this here. The height of this box in that direction will be equal to height of large gear, and in y directional the distance, as we said, is equal here to 2 millimeters. So I will call this distance between magnets. This distance is equal to 2 millimeters, and in x directional we will add here diameter of large gear outer diameter and multiply this by 1.1 and divide the result by 2 like this. And here let's make the center position height of large gear divided by 2 as shown here. Now let's duplicate this box 20 times and use angle equal to 360 divided by 20 as shown here. Now let's subtract all these boxes from the cylinder that contains the magnets. Go to edit and then select boolean here and then subtract, and subtract all boxes from the cylinder as shown here. Now right click on the cylinder number 1 and go to edit boolean and then separate all bodies like this. Okay. Now it's time to draw the back iron for this large gear. The cylinder of the back iron will be like this. Its radius will be equal to diameter of large gear divided by 2, large gear outer diameter divided by 2, and I will add this to 3 millimeter and use also here 100 number of segments, and the height here will equal to height of large gear, and here also divide this by 2 and click OK like this. Now let's draw the same cylinder but without this 3 millimeters and click here OK and subtract the small one from the large one, as shown here like this. Now let's give the outer or the back iron a color of gray color like this and hide it, and then we will select a group of magnets. Let's say this is the north magnets, and the other group will be or will have an opposite direction for magnetization. So I will give it here a color of red color like this. Okay. Now this is the geometry definition for the large gear. In the next video we will do the geometry definition of the small gear. So hope that you like this video and see you in next videos.